Mars, the red planet, a world that has fascinated humanity for centuries. For centuries it has beckoned us with its rusty glow, a beacon in the night sky that has inspired countless stories and dreams. It's a symbol of exploration, of pushing the boundaries of what's possible. From the early days of stargazing to the modern era of space exploration, Mars has always been a tantalizing target. Today, we dream of a future where Mars is more than just a distant neighbor. We imagine it as a new frontier, a place where humans can live and thrive. We envision a transformed Mars, a planet with breathable air and flowing water, a world where the barren red landscape is replaced by lush greenery and vast oceans. It's a bold vision, a true testament to human ambition. The idea of transforming an entire planet to make it habitable is nothing short of extraordinary. But is it really achievable? The challenges are immense, from the harsh environment to the technological hurdles we must overcome. Some scientists believe the key to unlocking Mars's potential lies in a surprising technology: nuclear power. This isn't about building cities or powering rovers. Not for building cities or powering rovers, but for something far more ambitious. They're talking about using nuclear explosions to terraform the planet. The idea is to release enough energy to melt the polar ice caps, releasing carbon dioxide and creating a greenhouse effect. It sounds like science fiction, but the idea has been debated in scientific circles for decades. The concept of using nuclear explosions to alter a planet's climate is controversial, to say the least. Could this controversial technology be the key to creating a second home for humanity? The dream of making Mars our second home is filled with both hope and uncertainty. As we continue to explore and innovate, only time will tell if we can turn this dream into reality. Our own planet is facing growing challenges. Climate change threatens our coastlines and weather patterns. Resources are dwindling as the population grows. It's a sobering reality that has led many to look to the stars for solutions. Could Mars be our lifeboat, a backup plan for humanity? The idea of colonizing another planet was once pure fantasy. Now it's a topic of serious discussion. If we can make Mars habitable, it could provide a refuge from Earth's problems and ensure the survival of our species. Before we start packing our bags, let's be clear. Mars is not a welcoming place. The average temperature is a frigid -80 degrees Fahrenheit. The atmosphere is incredibly thin, barely 1% as dense as Earth's, and it's mostly carbon dioxide, which we can't breathe. On top of that, there's the constant bombardment of harmful radiation from space. These are not minor inconveniences. These are fundamental challenges that would make survival on Mars incredibly difficult. That's why terraforming, the process of transforming Mars to make it more Earth-like, is so crucial if we ever want to live there permanently. Terraforming Mars is a monumental task. The red planet, with its barren landscapes and thin atmosphere, presents a challenge unlike any other. Scientists have long dreamed of transforming Mars into a second Earth, but the scale of this endeavor is staggering. It would require altering the planet's atmosphere, temperature, and possibly even its magnetic field. The Martian atmosphere is over 100 times thinner than Earth's, composed mostly of carbon dioxide with trace amounts of other gases. To make it habitable, we would need to thicken this atmosphere significantly. How could we possibly achieve such a massive undertaking? The challenges are immense, but so are the potential rewards. Scientists and engineers are exploring various methods, from importing gases to building giant mirrors to reflect sunlight. However, one of the most controversial ideas involves the use of nuclear technology. That's where the nuclear option comes in. The concept is both bold and contentious, sparking debates within the scientific community and beyond. The idea is to use nuclear explosions to kickstart the terraforming process. The idea is to detonate a series of nuclear bombs not on the surface but strategically in the Martian polar regions. These regions are home to vast amounts of frozen carbon dioxide or dry ice, which could be key to transforming the planet. Now, before you think this is pure madness, there is a method to this seeming mayhem. The explosions would be carefully controlled and targeted to maximize their impact while minimizing potential risks. The goal is to release the carbon dioxide trapped in the polar ice caps. The explosions would vaporize the frozen carbon dioxide ice at the poles. This process would release vast amounts of CO2 into the atmosphere, which could then act as a greenhouse gas, trapping heat and warming the planet. This vaporized CO2 would then be released into the atmosphere, potentially thickening it, and triggering a greenhouse effect. Over time, this could lead to a warmer, more hospitable environment with the possibility of liquid water and eventually, life. While the idea is still theoretical and fraught with challenges, it represents one of the many innovative approaches being considered in the quest to make Mars a new home for humanity. Section 5. The CO2 blanket warming Mars from the inside out. The greenhouse effect is often talked about in a negative light here on Earth. But on Mars, it could be the key to making the planet habitable. Here's how it would work. Sunlight can easily pass through the thin Martian atmosphere and warm the surface. However, the heat radiated back from the surface escapes just as easily because there aren't enough greenhouse gases to trap it. This is where the released CO2 comes in. It would act like a blanket, trapping the heat and gradually warming the planet. Section 6. The uncertain atmosphere. Will CO2 be enough? While releasing CO2 could potentially warm Mars, there's no guarantee it would be enough to create a truly Earth-like atmosphere. You see, Earth's atmosphere is a complex cocktail of gases, not just nitrogen and oxygen, but also trace amounts of others that are crucial for life. Furthermore, Mars lacks a global magnetic field like Earth's, which protects us from harmful solar wind. This solar wind could strip away any newly created atmosphere on Mars, rendering our efforts useless. Section 7. The radiation question: can we make Mars safe? Nuclear explosions, even in a controlled environment, inevitably release radiation. This is one of the biggest concerns surrounding the nuclear option for terraforming Mars. Even if the initial radiation levels were manageable, there's the issue of long-term contamination. Radioactive fallout could settle on the surface, making it unsafe for humans, and potentially harming any nascent life that might exist on Mars. Section 8. Time and technology. The challenges of terraforming. Terraforming Mars, even with nuclear technology, wouldn't be a quick fix. It would likely take centuries, if not millennia, to see significant results. And we're talking about technologies that are currently beyond our capabilities. We would need to develop powerful and efficient nuclear devices, devise safe detonation methods, and create systems to monitor and manage the environmental impact. It's a truly daunting engineering challenge. Section 9. Beyond nuclear, exploring other options. While the nuclear option has been on the table for a while, it's not the only idea for terraforming Mars. Scientists are exploring a range of alternative solutions, each with its own set of challenges and potential benefits. One concept involves using giant orbital mirrors to reflect more sunlight onto the Martian surface, thereby increasing its temperature. Another idea is to redirect comets or asteroids to collide with Mars, delivering water and other volatiles that could thicken the atmosphere. Section 10. A vision of the future. Mars with blue skies. Imagine a future where the once barren landscape of Mars is transformed. Lush vegetation covers the planet, rivers flow, and the sky is a brilliant blue. This is the dream that fuels our fascination with terraforming. While the challenges are immense, the potential rewards are even greater. A terraformed Mars could provide a new home for humanity, a chance to start over and create a better future. Section 11. The final frontier, a balancing act of risk and ambition. The idea of terraforming Mars, especially using nuclear technology, is fraught with ethical and practical concerns. The concept itself is both fascinating and daunting. On one hand, it represents the pinnacle of human ingenuity and our relentless pursuit of knowledge and expansion. On the other hand, it raises profound questions about our role and impact in the universe. Is it our right to alter another planet so dramatically, potentially disrupting any existing Martian ecosystem? The possibility of life, even microbial on Mars, adds another layer of complexity to this debate. If life does exist, do we have the moral authority to change its environment irreversibly? And even if we could do it, should we? The technological challenges are immense, but the ethical dilemmas are even more significant. We must weigh the potential benefits against the possible consequences, not just for ourselves but for any potential Martian life forms. These are questions that require careful consideration and open debate. Scientists, ethicists, and policymakers must come together to discuss the implications of such a monumental endeavor. The decisions we make today will shape the future of space exploration and our place in the cosmos. The quest to terraform Mars is a testament to human ambition, our drive to explore and push the boundaries of what's possible. It symbolizes our desire to reach beyond our home planet and make our mark on the universe. However, this ambition must be tempered with caution and respect for the unknown. But it's also a reminder of our responsibility to act thoughtfully and ethically as we venture further into the cosmos. As we stand on the brink of becoming an interplanetary species, we must ensure that our actions reflect not just our capabilities but our values and principles. The future of space exploration depends on our ability to balance risk with responsibility, ambition with ethics.